Okay, so let's start with chapter. Let's start with the lesson software engineering, and let me summarize what we are going to do today. So first of all, we are going to learn about some concepts. So about software engineering, what is the software, what is software development life cycle, why there is a cyclic process, and what are the phases of this SDLC. Then we will learn how to model or how to basically plan, because for anything before anything, this is engineering, right? Engineering is a systematic approach, therefore you need planning, right? Without a plan, it's very difficult to build a product. But general building or making something, making a cake or just making a small maybe puzzle, that doesn't need engineering approach, so you can just go and do that. So in coding also there is a method where you can go and start coding, that is called code like hell, right? You are not considering anything, nothing is considered, you go and create the software, that is called code like hell. That method is also there, but the thing is the systematic method that we are using, the systematic way is basically this design, and after that the coding, likewise testing. So there is an approach, we will learn about that. And then we will learn about the three concepts called sequence, selection, repetition. These are called control structured in programming, how we can control the flow of program, right? That is called control structured in programming, we will learn that. And after that, so we will move to the practical stuff. That is, you said that you are familiar with Scratch, and let's see how we can implement that using Scratch programming. And so by just how to model these, how to code sequence, selection, repetition in structured programming. Let's see a sample today. I encourage you to try the same, but so I will give you a sample code, right? Today, a sample implementation. Then, so there are some advanced, like this is a block-based programming, but when you are really coding, you have to learn in IDLE. So IDE is how to code. Like, so we will be learning about the main languages like Python and Java. Actually, we are not going to do it today, but gradually we will be moving to Python and Java programming too, because that is what the industry, if you want to move to the industry one day, if you want to move to the real world programming one day, you need to know about these languages, right? Therefore, we will be moving to that. Okay, on the today's lesson, so we will discuss some theories as well as we will be moving to stretch practicals related to those theories. Okay, let me begin. So is it clear to you, or any doubt you can ask, or any?
Okay.
And also note that this is your class, you can customize it. So if you feel bored, or if you feel upset, or if you cannot understand anything, repeat, ask it and can question it, because this is your class. Even though I'm going to support you, I just need to like centralize this around you, customize according to your need, right? Okay,
All right.
great. Software engineering, I said the engineering approach is a systematic approach. Actually, in this world, right, what we are doing with these computers or this technology is basically converting data into information. So data are raw things, raw facts. But if you come to information, it is meaningful thing. Example, so let's consider about this. Let's say white. So what is the meaning that you got when I say white? Yes, what is white?
Uh, like blank.
Yes, white.
Yeah, like blank and colorless.
Yeah, you can say it's a colorless or color or whatever. Okay, so see here. All right, this is the color white that I said. It can be the white, the Dulux white, which is a paint. Right, it
Yeah.
can be White House even. So White House in USA, what is White House?
Uh, like the place where the president is.
Yeah, as president's official place, White House, and it can even be white people. It can even be white people, but it's not same white, but here white, it can be white paint, White House, white people, or it can even be a person. So there some names, it's white. Example, Duncan White is the first athlete to win an Olympic medal in Sri Lanka. He's a person.
Yeah.
Now, like unlike like I said in the previously white, but it was a raw fact, white. You said it is colorlessness or color something, but now can you see? Now it has a meaning. When I say white people, there's a meaning. When I say white paint, there's a meaning. And if it is Dulux, there's a meaning. White House, there's a meaning. And Duncan White, there's a meaning. And here, so White House COVID response. So that has more meaning. So that has like further details. And here, so this is what called information, right? Information is something. So I think you can distinguish, understand the difference. Data are raw facts about something, someone, or some concept. But information is basically processed or meaningful thing, data. It has a more value and it's used for decision making, and it is an action motivator too. Right? Action motivator is used for the decision making, and these are the things. And another thing, red. Red is a data, but red data book is about information. If you heard of what is red data book, yes, do you know what is red data book?
No, I've never heard of it.
Yeah, it is basically about some species in the world are endangered, right? So there are some species are rare, some are in endangered state, so some need to be preserved. So this red data book is about those species. Right, red data book is about those species, right? Publication which provide information such as scientific common names, IUCN names, and also the global status and the conservation status of them. So that is red data book. It is not just the red book, it has some meaningful information. Okay, now you have basic idea how data is converted to information. It is done through processing. Okay, so then again, this is basically very important thing in the world, because especially in countries like America, the reason is, so if you know information, it's really valuable. So if you knew information about full information about COVID-19 virus and how it can be cured, how to face that, how to basically fight against this COVID-19, if you had that information prior to or maybe early stage in the situation, so maybe you can become a millionaire or billionaire. Why?
Because you would be able to find the cure and sell the cure.
Yes.
And you would get like prizes for finding it.
Yes, because entire world need your knowledge. So that is about information. It is valuable than gold. Right? Sometimes it is valuable than whatever the physical thing in the world. Right? That is information. That is how Bill Gates is so rich. So he got information. That is how the Apple, Mark Zuckerberg in Facebook, and then Apple owner, right? Whose name? What is the name? Cannot remember the name. Anyway, so if you search the top 10 richest people in the world, top 10 richest people in the world, most of them are dealing with information. You can see Bill Gates, Jeff Bezos, Warren Buffett, Larry Ellison. So here see, so all these people, basically this is Elon Musk. So what they process, they are basically dealing with information. Elon Musk, the owner of SpaceX, as well as he has invented this Tesla and all. So what he has, information basically. They have the secret recipe, what he's doing. And then here you can see, then some other people are also there. You can just go through their profiles and see. And Jeff, Amazon founder. Amazon is just set of information. That is one of the largest supermarkets in the world, but that exists in the information world, right? It
Yeah.
is Amazon. You don't have, maybe you have shops, yes, physically, but the thing is, in each country, you don't have a branch. Amazon branch in Sri Lanka, Amazon branch in Pakistan. You don't have such. But Amazon is a worldwide business. So it is information. Right? It is information. You can also become a seller in Amazon. And I can be a buyer or consumer or seller in Amazon. Right? That is, Facebook is the largest media company in the world. What they have? They don't have even agenda, a set of programs. TVs basically, they have program, news, some TV shows. Right? But Facebook, do it have such? Does it have such thing? No, it's not having anything. Only the content posted by the others, right? But it is the largest media company in the world. It earns in billions. Can you understand the value of information?
Yeah.
Right? So that is it. Okay. Then actually, what is software? Software is basically working with, in order to produce this information, so we need to build software. We need to engineer software to work with information. So since information is the most valuable economic resource in the world, then software creation process is critical. Because, so let's say you are dealing with most valuable gem in the world. Surely you should have a critical mechanism to protect that. Right? You have to give priority. Because if you're having the most valuable gem in your pocket, you have to give priority to yourself because you are valuable than earlier. Similar to that. So think about these people, Elon Musk, think about Mark Zuckerberg, think about Bill Gates, Larry Ellison, these people. So they need to have, so because every day, if you go to, there's a map called NORSE map. This is interesting fact. Maybe you have not heard before. NORSEMAP, NORSE map. This map is basically cyber attack map. Right, I'll show some images. You can just visit this websites and see that live. So this is what the NORSE map is. It is basically the live map showing the cyber attacks. Live map showing cyber attacks. There you can see China is attacking USA, USA is attacking China, China is attacking UK, and UAE is attacking some other countries. Likewise, people are attacking each other. How?
By taking or putting viruses.
Yes,
Cyber.
can be viruses, can be like denial of service attacks, DOS attacks. There are a lot in security, right? Anyway, people are attacking. So why these people are attacking? What's the gain?
Information.
Yeah, it can be information. And so what if, so in DOS, the main intention is to put the service down. Think if service WhatsApp down for 1 month, think about the loss. If service Facebook down for 1 month, think about the loss, right? At that time, another company can get popular, right? Within that time, a newcomer can enter the market and a new product can be promoted. So that is why this is called the cyber war. This is called the cyber. This live you can see when you visit these websites, I guess. This NoScope or threat map maybe. When you go and digital attack map, you can see them live, right? You can see them
Yeah.
live. But even though you can see them live, you cannot stop. Why? You can see live, they are attacking you, but you cannot stop that. What's the reason? And Russia is attacking themselves. Sometimes this can also happen. You can see the phishing attacks and different type of attacks, right? Israel attacks are going from different regions. Today, how many attacks today? 41 millions, right? 41 million attacks. No, very large amount. Very large amount of attacks. Even though you can see the live attack, why you cannot protect yourself? You can see here, one attack is going from here to Israel. Maybe fuel is the reason, or some other service is the reason. Yes. Even though you see this live, why you cannot stop?
Because even if you see it live, you can't really apprehend because it's already centered.
Yeah, it is already sent. And if you remove your computer, if you remove your server, and if you remove your network, or if you remove the service, that is what they also want, right? They also want to remove your service. If you remove your service thinking that if you down your server, or if you protect your server, if you disconnect it, then attacker is successful, because attacker also want to disconnect the server, right? Stop the service. Therefore, even though you know that they are attacking, only way to protect is basically your defense mechanism, your security mechanism. If it is good, you're protected. If it is bad, you'll be get attacked. Right. So this is the thing. So this is interesting domain. We will be learning this in computer security. This is because I have learned ethical hacking, and I am a certified ethical hacker. Therefore, I learned these things. But it is interesting thing to learn for anyone, right? Anyway, now you know how critical the software process is, because software need to protect this information, right? Okay. Do you think this MS Word is only used by me and you? No. It is even used by World Bank. It is used by Elon Musk also. It is used by like topmost people in the world. So if you type something, it need to be secure. Understood? If you type something in Excel sheet, even World Bank use Excel sheets, right? So that should be reliable, right? That should be reliable. Not just me and you, not just users like us, because these critical services are also rely on these applications. And we are not the only people using internet. It is used by World Bank. It is used by the Department of Defense USA. Right? It is used by President, ex-President Obama, and current president also. And it's used by companies, top richest companies. So internet, the running softwares within internet need to be protected. It should assure the protection. Therefore, software is critical and it needs engineering approach. So build the logic, right? So I initially said, what is data? Data raw facts. I will send this now. Right? Don't worry. If you want, you can write down important points. So data are basically raw facts. Information is taken after processing data, after organizing data, and software is basically dealing with information. So since information is one of the most valuable resource in the world, it needs to be well protected and assured. The process should be reliable. Therefore, the software creation is critical. So in recent past, 2019, 18, that period, so there was a reported crashes in Boeing 737 Airbuses or the flights, right? So there were, so basically Boeing, so if you search this crash, so you know the flight crash is basically, so it's pathetic, right? Why? So no one will survive, mostly. Everyone will die if it happens in the sky. So normally it's really critical here. This is the flight. The flight company had to land all the Boeing 737 flights for certain period. They couldn't fly. So the discovered reason, one of the reasons that they predicted was a software issue. So they thought that the software input or output which is given by the software is not properly understood by the pilots that time. That was the reason for this crash. Actually, closer to 3 flights or 2 flights or 3 flights crashed. So due to this software issue, think about the criticality of software engineering now. So it's easy to build. I know it is easy to build. You can go and code, go to Scratch, right? Drag some stuff, Maybe let's say go to the event. So this is where you are going to start, grab some stuff, then the control. Okay, let's say you want to do this forever, that is repetition, and you need to move 10 steps and forever. Yes, it happens. No need of engineering. And if it is in the corner, how to take it back? If it is in the corner, do you know?
To like get rid of it.
No, I just want to take it back. Actually, ask him to come back. Ask it to come back.
Negative 100.
Yeah, you can give the negative number, but there's another one.
Rotate.
You can do this if on edge bounce. If on edge bounce. Right? Now you can see it's bouncing, but it is like upside down. So you can say as rotation style to left, right only, right?
Yeah.
But forever this processor. So this is building. This is not engineering. This is building. And if you want to set the legs, you can go to the leg looks and you can switch to the next custom. And if it is too fast, you can slow down the process. And if it is too fast, you can slow down the process by going to control. Wait.
Wait.
But 1 second is too slow. You can put 0.1.
Probably 0.5.
Yeah, 0.5. That is, I think, it's also okay. It seems too slow. So likewise, so this is built-in, right? This is built-in. Yeah, this is a software. Yeah, it's okay. We are instructing the computer. That's true. But this is not engineering. This is called the code like hell method. You go and code. Right? You go and code. Possible. It is not impossible task. Possible. But keep in your mind, you're building or you're making this software, you're creating this software for the world. Sometimes the critical places this will be used, like flights. The software is used in a critical place. Sometimes people who are using your software relying on this. These people are top people in the world or top organization in the world. Therefore, the engineering approach we must learn, right? Engineering means a systematic, a carefully organized way of doing something. It is systematic and also a carefully organized way of doing something. It is called engineering, right? It is correct. It has several steps. Actually, this process is a cyclic process. Why it is cyclic? Because whatever happens in the beginning will happen again. History repeats. This happens in many places, right?
Yeah.
The fashion, phenomena, the things happen in the world, the phenomena. Even the rainy seasons like winter, autumn, summer, and spring. So all these things are, you can observe the world, all are cyclic. Wow. Even our life cycle, we will after a child birth, he or she will grow, become a teen, then the adult, then again he or she will be becoming grandma or grandpa and die. Again, it happens from the beginning. So that is the nature, right? In the world, because the world is rotating, right? World is rotating on axis, and it is revolving around the sun. The rotation and revolution, evolving, right? Rotation and moving around the sun. So both are cyclic. When one cycle completed, we call a day, the rotation cycle. But when it is moving around the sun, if one cycle complete, we call that a year. So everything is cyclic. So software, so do the software also. It is also a cyclic process. It will start with the problem definition. Why we need this? Otherwise, no software, right? Why we need? We should have a problem to solve. Right? Okay. For an example, Boeing 737 flight is no more flying. So there's a problem to that Boeing company. They should identify that is a problem. We cannot fly our flights. Oh, we need to do something on this. So they have come up with a new idea. They will find out what are the requirements. Unlike the earlier days, there was crash because of the wrong input, wrong output, or wrong prediction of inputs, something. So we need to figure out that. And we need to give it, maybe we need to make it easier to the pilot. So likewise, they will find the set of requirements and then they will plan. After the plan, they will come up with the actual code. But you cannot start flying now. You have to test. Test run is must. And after that, after testing out, everything is successful, you can hand it over to the users or the pilots. And people are using that. And actually, we cannot keep the same thing forever. We have to maintain gradually. Otherwise, again, the problem may arise. So we have to test and maintain it gradually, time to time. But after some time, so it will become outdated. You have to begin from the start. Okay, think about anything in the world, you can put it to this SDLC. This is sometimes called system development life cycle. Any system can be adapted or framed into this SDLC. Okay, think about the ancient road system in Egypt or some other country. Ancient transportation in, okay, let's, to make it easier, let's think about the Stone Age. In the Stone Age, the problem was to, why you think the Stone Age, why people need transportation at that time?
They didn't have transportation because they didn't have the technology to make it.
No, what I'm asking, what was the need? Actually, okay, think about the Stone Age. They didn't have anything called transportation.
Yeah.
But they are animals, they are locomotive. Locomotion is there. Locomotion is basically moving from one place to another place. That is a natural habit of animal, no? Okay, natural
Yes, to
habit of
move
animal.
from one place to another, like following food and stuff.
Yeah, that is true. Very good. So the problem is finding food. Exactly. So why they were moving? Because in one place, the food is not enough. Because you know the other properties of animals, they are not just locomoting, they are growing, and they are reproductive. They are generating their own kind, right? They're spreading. So when with the time, what will happen? The resources will not be enough. So then what? They have to find some other resources, find food. So moving is necessary. So what they have done initially, they might have observed how other animals are moving. So birds are flying. Can we fly? No. Fishes, they are basically fish. They are swimming. Can we? Difficult. Then these monkeys, they jump from one tree to another tree. Can we do? Still difficult because it's okay for some, but most of the, like in kids, for kids and adult people, it's a little difficult to do that same, maybe woman. So finally they thought, now we have a mechanism that is walking. But in order to walk, we need the proper path. That is the first kind of road. That is a footpath. The first kind of road that they have constructed. They have not done a formal process of engineering, but they had a problem. Then they analyze the requirement, what we do, how we do. And they have done feasibility study, the practicalness of that. Can we swim? Can we jump? Can we crawl? Can we climb? Can we hop? Likewise, they have found, they just analyzed the practically of that, finally decided to walk, the most practical solution. They have come up with the planning, whether are we going to walk east or south or north or west. So they have to plan which direction. Then initially, actual footpath was created by maybe like they have cleared some plants and maybe trees. They had planned and implemented that, but the testing was done right before moving. The entire tribe was not moving at the same time. First, the adults they tested, strong male adults in the tribe. They have tested. And after that, give it to the tribe, entire tribe. That is handing over the process. And it was there for some time, but after some time, they found it's difficult. So because time to time, you need to maintain, clear it. And also carrying the stuff is difficult because the path is so narrow. So carrying our stuff, maybe at that time they have started maybe cultivating some doing some agriculture also. So they had to carry their things, maybe with the animals they had to. Then the path should be wider. That is the next problem. It was never ending. After that, the fourth path was the wider path. And it can be a chariot path, something like that. And then they have they put tar and some other maybe stones and all to make it more comfortable. Finally, the carpet, right? Not even the carpet is not the carpet is comfortable, but the traffic is the problem. When traffic was the problem, then there were like highways. Likewise, the problem is never ending, right? That is the nature of the world, right? It's always okay. So now you know why SDLC. So software is also a cyclic process. We have to find the problem and analyze that and design for that and then develop the actual. This is what actually we are doing. We are learning throughout the program, throughout this course. We will be learning this part, but the thing is, you have to keep in your mind always we have to follow this, this, and this before this. That means you have to find the problem, understand that, find the requirement, design it or plan it, then only the coding, then it is easy. Finally, you have to test. You have to check whether it's working. Then only you can hand over. And time to time, you have to maintain. So that is it. Right? That is why, so actually, I have used DOS when I was learning ICT in 2000. Sorry, not 2000. I started learning ICT in 1996, even before you born. 1996. At that time, the operating system was DOS, disk operating system, DOS. It was CLI, only commands, black and white streams. No mouse was there. You had to type commands only. And then comes Windows 3.1, then Windows 95, 98, Windows Millennium Edition, Windows XP, Windows Vista, Windows 7, 8, 8.1, 10, 11. So what is the operating system in your computer? What is the operating system in your computer? Is it Windows? 10?
Yeah, it's Microsoft Windows. Yeah.
Is it 10 or 11 or 7? What's that?
Do you know where I can check from?
You want to share the screen?
Yeah, let me share my screen.
Okay, you are given the permission, can do it now.
Okay, so
wait, it's loading. Yeah, it seems it's Windows 11. Right, if you want to test that, yes, the mechanism is basically, you have tried that, good, right? The mechanism to test this is, we can go to this PC and then, so you can press Windows key and D key. Windows key and D key to minimize everything. Windows key and D key. Okay. Then please go to, is there this PC? No. Then go to the Explorer, the yellow color one.
okay.
Explorer.
Oh.
Okay. Then there's something called this PC in the.
Yeah, found it.
No, not there. You have to go to the view and put it like here. Navigation pane need to be displayed. Navigation pane. Click on the. All right. Okay. Now you can see this PC here. It's easy. Right click on that. Go to the properties. Right click on this. Select properties. properties. Then you can see details of your computer and what are the things here. This computer setup and all these things, and also the system type 64-bit. All these things are there. And just move down, you can see it's Windows 10 Home Edition.
Yes, Windows 10.
Windows 10 Home Edition. So it looks like 11, but it's Windows 10 Home Edition. Okay. So that is how you discover the operating system.
Okay.
So remember the stuff if you like. If you want, note down these things. Windows D for shortcut to show, like go to the desktop quickly to show all. You can press Windows key and D key. This is the shortcut. Then to see the properties, you can go to the Explorer, and on this PC properties, you can see the details of your computer. Okay, good. Then actually, so since I have explained this, I will send you the note on these processes. And actually, then you need to identify these symbols. This is how we represent a program. This is how we plan a program. Okay. Symbol is ellipse for starting and stop. Symbol is a process, is a rectangle. This is called a parallelogram for input and output. Decision is diamond. Connector is this, and this is for the data flow, arrows. So let's understand a plan now. This is actually used worldwide, right? If you use in Sri Lanka, USA, or if you even use in Moon, the same symbols are used, right? Therefore, right, you can easily understand the program. Why? Because if you write this in natural language, sometimes person to person, the understanding will be different. They will understand in different way. People will understand this in different way. But the symbolic notation, everyone can understand. Okay, example, see this. So start and end. This is where the program start and this is the end. And what is this input N1, N2, N3? It is a type of input, right? Because the symbol is this type of input. You have to put it. Actually, you have to get it from the user. Then total is this one. So what is that? It is a
process.
Process. Average is total divided by process. It is also a process. Right.
Yeah.
Display total and average. That is.
I just forgot the name.
So this is input. For input and output, both the symbol is this, right? So this is actually output. This is where you display something to the user. Input is where you take something from the user. Output is where you display something back to the user. Okay, let's convert this. So this is called a sequence. This is example for sequence. Sequence means things happen one by one. You can see it's a chronological order. One after another, one after another. There's a proper order. So things happen in order. We call them sequence. You move from grade 1 to grade 2, grade 2 to 3, 3 to 4, 4 to 5 in order. That is sequence. That is one way of writing programs. Okay, let's implement that in Scratch now. You have some idea about Scratch now. Let's implement this in Scratch. Can you do alone or you need my support to convert? Okay, so let me start a new one. Right? So start input N1, N2, N3. You have to input 3 things. Input 3 numbers actually here. Input 3 numbers. Here, this is the question. Input 3 numbers, add those, find the average and display. Input 3 numbers. So let's use the cat. To input 3 numbers, we can first introduce them as variables. In the orange color one, variables. So make a variable. I'm putting N1 for this. Okay. Make a variable N2. Make a variable N3. And you need to find out the total and average too. So make a variable total. Another variable average. Okay.
Okay.
Are you done with this or need help?
I'm almost done.
Almost done. Okay. Tell me once you're done.
Okay.
Now we have variables, right? You can see these variables are displayed here. If you don't want to display, you can untick them. You can then hide by unticking them. That is up to you. But I would like to display them to the user. So I'm putting these variables. Except this my variable, other variables I want to display here. Okay. Now what? Input. Input can be done using, first of all, you have to go to the event and when flag click start. Okay, let's display a message. Okay, let's display a message. All right, you can do that using sensing. Ask, enter number 1, the first one, first number. Then when you click this, it will ask, enter number 1. Oh, enter number 1. If you need the voice support, you can add it too. Right? Sometimes you need to add the voice support. If you need voice support, you can go to this one. This is extensions. Can you see this corner? It is a bottom left corner. Add extension. There is something called text to speech. 1, 2, 3, 4. 1, 2, 3, 4. Text to speech. So then from that you can add speak. And here you can add enter number 1. Okay, let's see. This should come before.
Enter number 1. Enter number 1.
Now it's giving the
Enter number 1.
voice.
Yeah.
Right, it's giving the voice command.
Yeah, it's
Okay.
giving the voice for me.
Sorry.
It's giving the voice for me.
Yeah. Then you can, if you don't like this voice, you can change it to tenor or a giant or kitten. But I like alto. Let's put tenor. Set voice to tenor.
Enter number 1.
Right. You can change it, right?
Yeah.
Okay. So I'll keep as it is and let's move into sensing again. Then, right.
Enter number 1.
Okay. Go to the variables, set. Use the set command, and then you can set N1 to, from this sensing, you can get the answer. Right here. Let me press.
Enter number 1.
Then I'm typing some number and press enter. You can see it is there in N1 here. It is stored here. After storage, you can read it out to the user to get them aware. Speak. I have to tell the number from the variable N1. Okay, let's see now.
Enter number 1. 67.
It's reading, but it should be sensible, right? Not just 67. I have to tell you have entered 67. Let's make it. To do that, you can go to the operations. From that, join apple and banana. Take join apple and banana. But this time not apple and banana. I can say you have entered N1. Now,
enter number 1. You have entered 87.
okay. My number 1 process is done. Now you have to go. Yes. Now I'll show you the plan. I think you have an idea. Right? You have an idea what to do now. Let's see how you can apply this, because it's very important in programming, because as a tutor or teacher or lecturer, whoever you say, I cannot be behind you always, guiding you, telling you do this, do this, do this, do this. So you have to think and apply. So this is my guidance. Now you can repeat for N2 and N3 and try to get the total average and display them. So let's see. Right? The challenge is to you. You have to repeat the process simply. Try it. You can do it. You can do one once you have a problem, maybe you have difficulty.
Enter number 1. Enter number 1. You have entered 1. Enter number 2. You have entered 2. Enter number 3. You have entered 47.
Okay, so I did all the numbers.
Great, I heard that. Then the next phase is finding the total. Can you give a try? Okay, what you have to do is you have to basically repeat them. Right? This is what I think you have done. There's an easy way. Easy way is what? You can right click on the particular
Enter number
page.
1.
And you can right
Yeah,
click on
you have to disconnect it from the one click button and then you can duplicate it.
Yeah, duplicate it. Yeah, that's true. Or without disconnection also, you can just click on the specific part and duplicate. Here, this one you can do. Then also, if you click on the right one, that will happen, right? Then actually enter number 1. The second one is enter number 2, TWO, and enter number 3, THRE. And make sure you have to change these variable names. N1 need to be changed, N2 need to be added, N1 need to be changed, N3 need to be added. Okay. Now N1 is there. Here you have to change it to N2. Here you have to change it to N3. Okay, all 3 numbers. Now let's try.
Enter number 1. You have entered 76. Enter number 2. You have entered 45. Enter number 3. You have entered 32.
Now you can see all 3 numbers are stored. Variables. In programming, variables are very important thing. These are going to hold the values which are collected from the input or collected as the inputs. So these things will be held or kept in these memory locations. These are memory locations. It's like a mug. It's like a cup. In the cup, you can keep water or tea or coffee or cold drink, anything. And there is a maximum amount and the minimum amount. Minimum is 0 basically. The maximum is the cup, full cup. That is the maximum. Maybe 300 milliliters, something like that. The variables are also same. There's a minimum and maximum you can store. But in between that, any value you can store. If you try to store more than that, it will overflow. Similar to that, the variables will overflow. Right? If you maybe give an error. right? Similar to that, it can store different variable values. Variable means change in values. Time to time, amount of water in the cup can change. Right? That is what the variable is. So it's very important. Now the total variable is waiting for these numbers. How can we do? Okay, you have to go to the operations. There's something called addition here. You can use that.
Yeah. Use the addition and get two of them. Put one of them together, and then you have to plug in the N1, N2, and N3.
Yeah, that's true. So you have to take this. That's what I asked. You can do it. You have to merge them together. So then what you need to do? You have to go to the variables, N1, N2, N3 need to be added and assign that to the total variable. That can be done. Set total to N1, N2, N3. Correct. That is the way. And if you want to find the average, same. Set average.
Number 2.
Set average
Okay.
to. What is average then? Set average to. You have to get the division, right?
Yeah. So then you would have to divide the total by 3.
Correct. Exactly. Very good. By 3. And assign that to the average variable. Clear. So this is what the sequence is. You can see all the instructions moving down smoothly. Sequence. No repeatings, no decisions, nothing. All the instructions are falling down smoothly. So we call that sequence control structure. Sequence control structure. Okay, you can read it out to the user also because this will be calculated for sure.
Enter number 1. You have entered 65. Enter number 2. You have entered 35. Enter number 3. You have entered 99.
You can see it is calculated, total average calculated, but the problem is it is not read out to the user because we have to think about our program. Initially, we had started with the voice, then at the end also it is better to speak out and tell that. And I will use this join apple banana again, and I'm telling that let's make it meaningful. I'm joining apple banana again and joining apple banana again. So what I'm going to do? Then what I'm going to do is I'm going to tell something like this from the variable N1. Then I'm telling plus N2. I need another apple banana, right? This is length here. N1 plus N2 is then the total. And then this statement will be really meaningful. Right? Let's speak out. What you have to do? You have to speak this. Okay, let's see.
Enter number 1. You have entered 65. Enter number 2. You have entered 34. Enter number 3. You have entered 77. 65 plus 34 is 176.
That is meaningful, right? Rather than total is this one. I can just say 6, but I have another number, right? I forgot that.
Yeah, you need to put the N3.
Yeah, you have to put the number 3 also. Okay, do this for number 3 as well as for the average. You can, or you can directly sell the total is this. Oh, I'm using the another one. Another apple banana, another plus, another apple banana, 6. Now here, then N3, N2 plus N2 plus N3, N3 is okay. Now you have all 3 numbers.
Enter number 1. You have entered 55. Enter number 2. You have entered 44. Enter number 3. You have entered 88. 55 plus 44 plus 88 is 187.
Find with the average. Let's make it simple. Average is then the average. Finally, you can say something to say goodbye. Thank you. Okay, that's it. So, have you done this?
I'm almost done with the average.
Ah, okay.
Okay.
Right. Okay. Summarizing again. Right. Under the today's lesson, what we have learned. Under the today's lesson, we have learned the importance of information to the world, and it is one of the most. It is not one of the most. It is the top, right, economic resource in the world. If you have information about something, you are rich, right? So, especially entrepreneurship is promoted in USA, you know. So everyone need to be independent financially one day. So that is the idea of that. That is the idea. But so what is the investment? Investment is information. So Mark Zuckerberg invested his idea, information. Facebook began. Elon Musk invested on his idea, information, and then the SpaceX and this Tesla, those began. Then the supermarket, that is Amazon. So Jeff Bezos, he has invested on his information. So everyone found their own way of investing on this most valuable economic resource, which is information. Even if you create a vaccine for COVID-19, that is about information. So information can be converted. That means some financial aid or support, that is for true. But some information, you can start with zero. So there are such things. Some information, you can start with zero even, right? But it depends on the idea. So if it is a mechanical or electrical or electronic or product, so then sometimes you need to invest on a factory. Anyway, software is basically dealing with all these information related tasks. So because information is intangible, you cannot touch, right? Software is the mechanism, that is the engine, right? Where information is processed or information is generated, communicated, handled, stored. So everything works with the software. Therefore, software need to be engineered. We learned the engineering approach. Engineering approach is a systematical way, step-by-step systematical way of doing something. Carefully organized sequence of steps. We learned the process called SDLC. That is the engineering process that we have learned. But this process can be applied in different ways in future. In maybe advanced steps, you will be learning about agile programming, Scrum, and pair programming like Think, and then spiral model, waterfall model. There are a lot. This is just the beginning, right? But in the beginning, you just need to know the steps. Then we saw it is a cyclic process. It's repeating. Because if you invest on building 3.1, this is not your end. This is just a start. So otherwise, Bill Gates will start introducing Windows 3.1, and after that, Bill Gates will no more. So he will be not there. But after that, another product. So even after Windows 11, he will come up with another product. Right? That is the nature. That is how you survive in the market. Right? It's a repeated process. So then we learn the planning method. How can we plan? What are the symbols for planning? And we quickly converted one plan into a code. When the plan is there, it's very, very easy to convert that plan to a code. That's why the plan is important. And I said that this is called sequence because the plan is moving down smoothly one by one. Okay, next day we have to learn about the other things like selection and repetition. So let's do that next. Okay, then do you have any question to be asked? Like any question?
No, I don't have any questions.
Okay. Are you happy with the session? So is it okay for you?
Yeah.
Okay, great. Like, okay, let's do this the next day then. Okay, goodbye.
Okay.
See you.
Bye.
Okay.